Hello everyone, myself Ritika Tyagi. Today we are going to discuss class 10th chemistry chapter chemical reactions and equations, that is chemical equations, balancing of chemical equations, then types of chemical reactions, and the last topic is the effect of oxidation reaction in our everyday life. Let's start the lecture. Let's start the topics. The topic which we are going to discuss is chemical equations. What are chemical equations? How we represent it? We discuss in this topic. The method of representing a chemical reaction with the help of symbols and formulae of substances involved in it is known as a chemical equations. Means chemical equations is a representation of a chemical reaction in which we represent the substances with the help of their symbols, and also we can represent their state, that is G for gas, L for liquid, and S for solid. So this representation of a chemical reaction is known as chemical equation. Chemical equation is simply the representation of substances which take part in a chemical reaction with the help of their symbols and formulae. For example, here hydrogen is gas H2 and oxygen is also gas O2, react to form a product, that is water, liquid in state L. Of chemical reactions we discuss in later session. Next example is acid, sulfur. React with oxygen molecule, 12 molecules of oxygen, then it form 8 molecules of sulfur trioxide, SO3. The next reaction is decomposition reaction. Decomposition means breaking. Here a single reactant break down to form two products. That's why this reaction is a decomposition reaction. Here 2 molecules of mercuric oxide decompose to form 2 atoms of mercury and 1 oxygen molecule. The last reaction which is representing here is that zinc react with chloric acid, then it form a salt, that is zinc chloride, and release the hydrogen gas. We already discussed in the evolution of gas section the detection test of hydrogen gas. The hydrogen gas burst with a pop sound. So chemical equations is a simple representation of a chemical reactions with the help of the substances formulae which we discussed, that hydrogen and oxygen react to form water, sulfur react with oxygen to form sulfur dioxide, mercuric oxide decompose to form mercury and oxygen, zinc react with hydrochloric acid to form a salt, that is zinc chloride, and releasing hydrogen gas. We are going to discuss the next topic, that is balanced and unbalanced chemical equations. What are balanced chemical equations? What are unbalanced chemical equations? How do we balance the unbalanced chemical equations? All these questions we are discussing here. Balanced chemical equation. It has an equal number of atoms. It has an equal number of atoms of different elements in the site of reactant and product. Means number of reactant is equals to the number of product. Then we get balanced chemical equation. For example, let me consider hydrogen molecule react with oxygen molecule, then it form 1 molecule of water, that is H2O. Now here hydrogen atoms are 2, oxygen atom also 2. Here hydrogen atoms 2, but oxygen atom is only 1. So it is an unbalanced chemical equation now, because number of oxygen atoms are not balanced here. Multiply water molecule by 2. Then we get hydrogen atoms total 4. 2 to the 4. And oxygen atoms 2. Now oxygen atom 2, oxygen atom also 2 in product side. Hydrogen atom on reactant side 2, but hydrogen atom on product side 4. Now hydrogen is not balanced. So we have to write 2 in front of hydrogen molecule on reactant side. Then we get total 4 hydrogen atoms which balanced product side. Oxygen atom on reactant side 2 and oxygen atom on product side also 2. Hydrogen atom on reactant side 4, hydrogen atom on product side also 4. So now This equation is a balanced chemical equation. When the number of molecules on the reactant side is equals to the number of molecules on the product side, then we get a balanced chemical equation. And on balancing the chemical equation, we follow the law of conservation of mass. That is, it obeys the law of conservation of mass. Balancing of chemical equation obeys the law of conservation of mass means mass can neither be created nor destroyed but can be converted from one form to another. It means here reactants react with each other, then they form a new substance with new properties, that is product. But overall mass of the reactant molecule is equals to the mass of product molecules. So it obeys the law of conservation of mass. The sum of masses of reactant is equals to the sum of masses of the product. That is the statement of the law of conservation of mass. Here, iron reacts with oxygen molecule, then it forms Fe3O4. Now we have to balance it because it is not a balanced chemical equation, because on product side Fe atoms are 3, but on reactant side Fe atoms only 1. So we have to multiply Fe atom on reactant side by 3 to get equal number of atoms on both sides. Similarly, we have to balance the oxygen atoms. On reactant side, oxygen atoms are 2 and on product side, oxygen atoms are 4. So we have to multiply on the reactant side oxygen by 2. That is 2 to the 4 and it is also 4. Now it is a balanced chemical equation. The topic is unbalanced chemical equations. What are unbalanced chemical equations? As we know, balanced chemical equations when the number of reactant molecule is equals to the number of product molecule. In unbalanced chemical equations, the number of reactant molecule not equal to number of product molecule. Simple, it is an unbalanced chemical equation. It has unequal number of atoms of one or more elements in the reaction. Means number of elements are not equal here on reactant side as well as product side. It does not obey the law of conservation of mass because the reaction is not balanced. So mass on the reactant side not equals to the product side. So it does not follow the conservation of mass. Sum of masses of reactants not equal to the sum of masses of product. Here mass of the reactant not balancing the mass of the products. Either mass of the product is higher than the mass of reactant or lower than. Both cases are possible in unbalanced chemical equation. Let us take a look of this example where magnesium atom react with oxygen molecule, then it form a magnesium oxide, that is white powder, we discussed in previous session. So here magnesium atom on reactant side 1, oxygen atom on reactant side 2. Right hand side, that is on product side, magnesium atom 1 whereas oxygen atom also 1. So here oxygen atoms are not balancing, so it is an unbalanced chemical equation. Balanced chemical equations, the equations which obeys the law of conservation of mass. Unbalanced chemical equations, the equation which does not obey the law of conservation of mass. In balanced chemical equations, mass of the reactant is always equals to the mass of the products. In unbalanced chemical equations, mass of product never equal to the mass of the reactants. Now here is a question on the base of balancing of chemical equations. We have to balance these chemical equations. Sodium atom on reactant side 1, sodium atom on product side 2. So sodium atoms are not balanced. Similarly for oxygen, oxygen atoms on reactant side 2 and oxygen atom on product side 1. So we have to balance first oxygen atoms. Here oxygen atom 2 on reactant side and on product side only 1. So we have to write 2. So we have to multiply sodium oxide by 2 so that number of oxygen get balanced. So now oxygen atoms 2 on reactant side and now oxygen atom also 2. 2 ones are 2 on product side. So we have to balance the number of oxygen. Now let us take sodium atoms. Sodium atoms 1 on reactant side whereas sodium atoms on product side 4. 2, 2. So we have to multiply sodium atom on reactant side by 4 so that we get 4 sodium atoms on reactant side also. Now sodium atoms on reactant side 4, sodium atom on product side also 4, 2 2s are 4. Oxygen atom on reactant side 2 and oxygen atom on also 2. So now it is a balanced chemical equation. Next equation, hydrogen peroxide. Decompose. Decompose means breaking or split up. Then it forms two products, that is one water molecule and one oxygen molecule. Here on reactant side hydrogen atoms 2, oxygen atom also 2. But on product side hydrogen atoms 2, on product side hydrogen atoms 2, but oxygen atoms overall 3. 2 here and 1 here. So we have to add up all these oxygen which are present in product side. So we get 3 oxygen atoms on the product side. Now we have to balance this oxygen atom first. Here 2 is an even number and 3 is an odd number. So first we have to balance the odd number. Here 1 is an odd number, so we have to multiply this by 2 so that we get an even number, because even numbers are balanced easily. Now total 4 oxygen atoms on the product side, 2 here and 2 this oxygen atom. But on reactant side oxygen atoms are only 2. So we have to multiply on reactant side by 2 so that we get total oxygen atoms 4. 2 2s are 4. Oxygen atoms are 4 on reactant side and oxygen atoms also 4 on the product side. So oxygen atoms are balanced. Now hydrogen atoms 4 on reactant side, that is 2 2s are 4. Hydrogen atom also 4 on the product side, 2 2s are 4. So now it is a balanced chemical equation. Third equation, magnesium hydroxide react with hydrochloric acid, then it form magnesium chloride and water molecule. Here magnesium atoms 1 on the reactant side, magnesium atom 1 on product side. Chlorine atoms 1 on reactant side but chlorine atom 2 on product side. So first we have to balance these chemical atoms. Here we have to multiply 2 on reactant side because reactant side has only 1 chlorine atom whereas product has 2 chlorine atoms. Now we get 2 chlorine atom on both sides. Magnesium 1 and 1 already balanced. Now hydrogen 2 and 2, overall 4 on reactant side. Hydrogen only 2 atoms on the product side. So we have to balance it by multiplying it 2. That is 2 2s are 4. 4 hydrogen atoms on the product side and now reactant side 2 hydrogen atom and 2 hydrogen atom. Overall total 4 hydrogen atom on reactant side and overall 4 hydrogen atom on product side. So hydrogen atoms are also balanced. Now oxygen atom 2. Here it is in bracket. So we have 2 oxygen atoms. Now multiplying 2 to this water molecule, we get 2 oxygen atoms. 2 oxygen atom on reactant side, 2 oxygen atom on product side. So now it is a balanced chemical equation because all the atoms of this equation are balanced. That is magnesium 1, magnesium 1, chlorine 2, chlorine 2, hydrogen 2 and 2 4, hydrogen atom 2 2s are 4, oxygen atom 2, oxygen atom also 2. So now it is a balanced equation. Next equation, fourth, iron react with oxygen, then it forms Fe2O3. Now oxygen atoms 2, oxygen atom 3. When we get 2 and 3 relation in any equation, first we have to multiply. 2 3 ja 6. So we have to balance the equation according to 6 atoms. So first here 2 oxygen atoms are present. I multiply it by 3 so that it becomes 6. 3 2s are 6. Now here on reactant side oxygen atoms are 6 and on product side oxygen atoms only 3 and 3 2s are 6. So now oxygen atoms on the product side also 6. Next we have to balance the iron atom. Iron atom on the reactant side only 1 atom. Iron atom on the product side 4. 2 2s are 4. So here is a shortage of iron atom on the reactant side. We have to balance according to 4, according to product. So we have to simply multiply it by 4. So it is a short trick to multiply 2 and 3 relation. Here oxygen are 2 and oxygen are 3. When you get 2 or 3 number of atoms in a reaction, so first you have to balance according to the 6 atoms. 2 and 3 taking LCM, that is 6. So I multiply 3 oxygen by 2 and 2 oxygen by 3. That is overall 6 oxygen atoms. Now we have to balance the iron. Iron here 4. So simply multiply by 4 so that iron atoms on the right hand side also becomes 4. Now last equation. Aluminium hydroxide decomposes to form aluminium oxide and water molecule. So here aluminium atom 1 on reactant side, aluminium atom 2 on product side. So we have to multiply 2 on reactant side because reactant side has shortage of aluminium. Now hydrogen, overall hydrogen atoms 3 and 2. 2 3 6. Overall 6 hydrogen atoms present on the reactant side. We have to product this 2 and 3 and we get 6 oxygen atoms, 6 hydrogen atoms. Now hydrogen atom only 2. So we have to balance according to 6. 3 2 6. Now hydrogen atoms are balanced. Next oxygen atoms. Here oxygen atoms also 6. 2 3 6. Because it is a bracket and outside the bracket is it 3 and we have put already 2 and 2 3 6. So overall 6 oxygen atoms present on the reactant side. Now on product side 3 oxygen here and 3 oxygen here. Overall 3 plus 3 6. So it is a balanced chemical equation. Now aluminium 2, aluminium 2, oxygen 2 3 6, oxygen 3 and 3 6, hydrogen 3 2 6, hydrogen 3 2 6. So in this way we can balance and unbalanced chemical equation. Now we are going to discuss the most important topic of this chapter, that is types of chemical reactions. Most important from examination point of view. The first reaction, combination reaction or simple addition reaction. The first type of reaction is a combination or simple addition reaction. As the name suggests, addition means jod. Here A plus B add, we get a single product, that is C. We can simply identify it that on reactant side more than 2 or more reactants are present, but on product side only one single product is present, always in addition or combination reaction. It is a simple identification for addition reaction that on reactant side 2 or more reactants are present, but on product side only a single product is always present. The next reaction, decomposition reaction. Decomposition means breaking, split up. Split up. As the name suggests, breaking or split up means tootna. Right. C, break up to form 2 or more simpler products, that is A plus B. So here C is a single reactant and it forms 2 products. Not necessary only 2 products, more than 2 products also possible. So as you see here, in addition 2 or more reactant combine to form a single product, but in decomposition a single reactant decompose or split up to form 2 or more than 2 simple products. So these 2 reactions are exactly opposite to each other. Next, displacement reaction. As the name suggests, displacement. Dis plus place. Any change in place of an atom. Let us take AB is a solution. Here C is present. Let C is more reactive than B. So it displaces the B from A and take its position. So we get AC plus B. So it is a simple displacement reaction that C is a more reactive element compared to B. So C displaces the B from AB solution and we get a product that is AC plus B. A single atom displaces another atom from its salt solution. Then it is a displacement reaction. The fourth type reaction is double displacement reaction. As the name suggests, double. Here 2 atoms displace each other positions. For example, let AB is a solution and CD is also another solution. Now D displays B, or we can say B displays D. So we get a new product, that is AD plus CB. So here both atoms exchange their position B as well as D, and we get new products with new properties. So it is a double displacement reaction. The fifth type reaction which we are going to discuss, that is redox reaction. As the name suggests, redox, red plus ox, means here first kind of reaction is reduction and second type of reaction is oxidation. So it involves two types of reaction, that is oxidation and reduction reactions. The first type of reaction which we are discussing is combination reaction, or simple we can say it is addition reaction, because in this reaction two or more reactants combine to form a single product. These reactions in which two or more substances combine to form a single substance. Two or more substances combine to form a single substance and are called combination reactions. Two or more substances combine to form a single substance. General equation for this, A plus B equals to C. Now hydrogen molecule H2 react with nitrogen molecule N2, then it form the ammonium molecule, that is NH3. Now we have to balance the equation. So hydrogen 2 atoms, nitrogen 2 atoms. Here nitrogen atom only 1 and hydrogen atom are 3. So first we have to balance these 3 and 2. As I say, 2 3 is 6, taking the LCM of 2 and 3. So we have to multiply 3 by 2 and 2 by 3. We get total hydrogen 6. 2 3 is 6 and 3 2 is 6. Now we have to balance the nitrogen atom. Here nitrogen atoms are 2 and nitrogen atoms get 2. So it is a balanced chemical equation. Magnesium oxide react with carbon dioxide, then it form magnesium carbonate. Here magnesium atom 1, magnesium atom also 1, carbon atom 1, carbon atom also 1, oxygen atom total 3, 2 here and 1 is here. Total oxygen atom on left hand side 3 and total oxygen atom on product side also 3. Is no need to balance this equation. This equation is already balanced because number of magnesium, carbon and oxygen atoms are equal on both reactant and product side. Next, carbon monoxide, that is CO, react with oxygen molecule, that is O2, then it form the carbon dioxide molecule. Carbon is 1 on reactant side, carbon 1 on product side. So carbon atoms are balanced. But now oxygen atoms total 3 on reactant side, 2 here and 1 is here. So total overall 3 oxygen atoms are present on reactant side, but only 2 oxygen atoms are present on the product side. So we have to balance the oxygen atoms now. First we multiply this one oxygen atom by 2 so that we get an even number. Then we multiply 2, we get 2 and 2, overall 4 oxygen molecule. So we have to multiply it also by 2, 2 and 2, 4. Carbon atom 2 and carbon atom also 2. So now it is a balanced equation. Simple combination action, 2 or more substances combine to form a single product. Example, hydrogen and nitrogen molecules react to form a ammonia molecule. Magnesium oxide react with carbon dioxide, then it form magnesium carbonate. Carbon monoxide react with oxygen molecule, then it form carbon dioxide molecule. So now we are going to discuss the second type of chemical reaction, that is decomposition reaction. What are decomposition reactions? Those reactions in which a compound splits or break up into 2 or more simpler substances are known as decomposition reaction. Means here a single substance break down to form 2 or more simple products. Here for breaking this C substance we have to supply some type of energy, either it is heat, electricity or light. On the basis of this, there are 3 types of decomposition reaction, that is thermal decomposition by supplying heat, electrolytic decomposition by supplying electricity, and photo decomposition by supplying light energy. So there are three types of decomposition reaction on the basis of type of energy we supplied for the breaking of the substance. It is thermal decomposition, electrolysis or photo decomposition. Note, a decomposition reaction is just opposite of a combination reaction. As I already discussed, A plus B combine to form C. Then in decomposition reaction, C break down to form A plus B. So it is addition reaction, but now it is decomposition, and both of these are exactly opposite to each other. Here is simple representation for this. A and B atoms combine to form a molecule, that is AB. We supplied some type of energy for its bond breaking. Then it forms single atom of A and single atom of B. Similar example of zinc carbonate. When zinc carbonate heated, then it formed zinc oxide and carbon dioxide molecule. So it is an example of decomposition reaction. The third type of reaction is displacement reaction. What are displacement reactions? Those reactions in which one element takes the place of another element in a compound are known as displacement reaction. Means here A and B combine to form a molecule, and C atom that is more reactive than B. So it take out B from A and form new product A and BC molecule, A atom and BC molecule. So here more reactive element displaces the less reactive element from its compound. So we can consider that here C is more reactive, and A is less reactive, because C displaces A from B. So it is a simple displacement reaction. Here, as it is shown, there are some examples of displacement reaction, and it is a reactivity series of metals. Most important reactivity series for metals, and to understand the displacement, which element or which metal displace one another, we understand from this reactivity series. First, let us take example. Potassium react with water molecule, then it form potassium hydroxide and release hydrogen gas. So here potassium displaces the hydrogen from water molecule, that is release the hydrogen gas. So here potassium is more reactive than hydrogen. In reactivity series also hydrogen is present below and potassium is at the top of the series. So at the top potassium is more reactive. Potassium is most reactive element of this series, and it can displace all other elements which are present at the bottom of it. Second example, magnesium when react with copper nitrate, then it form magnesium nitrate and copper. So here magnesium displaces the copper from copper nitrate and we get magnesium nitrate and copper. Copper displaces here. So here magnesium is more reactive than copper. As it is shown, magnesium is at the top and copper is at bottom. So magnesium can displace copper easily. Next here, zinc react with hydrogen chloride to form zinc chloride and hydrogen. So here zinc displaces the hydrogen from hydrogen chloride and release hydrogen gas. So we can say that zinc is more reactive than hydrogen. As it is shown, zinc is present here, hydrogen is present below the zinc. So zinc can displace the hydrogen easily. Here chlorine react with calcium iodide and form calcium chloride and iodine. So here chlorine is more reactive than iodine, hence it displaces iodine from calcium iodide and form calcium chloride solution. So here reactivity series of halogen is as fluorine, chlorine, bromine and then iodine. Here fluorine is more reactive than chlorine, then bromine and then iodine. So fluorine can displace chlorine, bromine or iodine. Now chlorine displaces bromine and iodine, and bromine displaces only iodine from any solution. So it is the reactivity series for halogens which is applying here. Now let us take a look of this reactivity series of metal. Here potassium is at the top, most reactive metal. Element sodium, symbol Na, calcium Ca, magnesium Mg, aluminium Al, carbon C, zinc Zn, iron Fe, tin Sn, lead Pb, hydrogen H, copper Au and platinum Pt. So the question is that how do we memorize this series of element, this reactivity series of element, so that we can apply easily for any reaction. For completing the displacement reaction, we must have the knowledge of this reactivity series of metals, and memorizing point is that potassium is the most reactive metal from all other elements or metals, and platinum, gold, silver, copper, these are least reactive metals, and hydrogen and carbon are the two known metals which are included in this reactivity series. Now we are going to discuss the fourth type of chemical reaction, that is double displacement reaction. What are double displacement reactions? Those reactions in which two compounds react by an exchange of ions to form two new compounds are called double displacement reactions. Here two compound 1 and compound 2 react with each other and they exchange their ions, that is B get the position of D and D get the position of B. As shown here, A combine with D and C combine with B. When two ions exchange each other position and we get two new compounds, then it is a double displacement reaction. Here is an example of potassium bromide. Then it forms potassium nitrite and silver bromide. If we take ions, then potassium is K positive, bromine is Br negative. Similar here, silver is Ag positive, nitrate is NO3 negative. So now ions exchange, positive attract negative potassium, positive attract negative nitrate, and silver positive attract negative bromide. It is a formation of potassium nitrate and silver bromide. So it is a double displacement reaction. Simple comparison between displacement and double displacement reactions. Displacement reaction. In a displacement reaction, more reactive element displaces a less reactive element from a compound. That is AB plus C, then it forms AC plus B. So a more reactive element displaces a less reactive element. Next, in double displacement reaction, two atoms or group of atoms switch place to form new compounds. In a displacement reaction, one displacement takes place, only single displacement takes place. That is, in a double displacement reaction, two displacement take place to complete the reaction. That is, A comes with C and B comes with D. Change of color takes place, no precipitate formation, precipitate formed. So double displacement reactions, formation of precipitate occur, whereas in single displacement reaction only changing of color take place. Metals react with salt solution of another metal. Here metal displays one another. Salt solution of two different metals react with each other. Here salt solution of two different metals react and exchange their ions to form two new compounds. Let us take a look of color changing reaction. How color changing reaction takes place? Let us take an example of it. Copper sulfate solution. When we dip an iron rod in it, then it formed ferrous sulfate FeSO4 plus copper. Here iron is more reactive than copper, so iron displaces the copper from copper sulfate solution and form iron sulfate plus copper deposit on this iron rod. So now here the color of this solution is blue. Copper sulfate is a blue solution or blue vitriol. It is also known as blue vitriol. But the color of ferrous sulfate is greenish. So it is a color changing reaction. So we can displacement reaction, color of the solution gets changed, whereas in double displacement reaction, precipitate formation occurs. Here BSO4 is formed. So this BSO4 is solid and this BSO4 is a white PPT. So in double displacement reaction, precipitate formation occurs. The last type of chemical reaction, that is redox reaction. Here, as the name suggests, red plus ox. So two processes involved in redox reaction. First, reduction. It is reduction, and ox stands for oxidation. Oxidation reaction. Oxidation and reduction reactions are called redox reactions. When oxidation and reduction reactions take place together or simultaneously, then it is known as redox reaction. Copper oxide react with hydrogen, then form copper plus water. So here copper has oxygen, but in product copper oxygen get displaced. Copper loses the oxygen. So when a substance loses the oxygen, then it is known as reduction. Similar for hydrogen, hydrogen get the oxygen and convert into water. So when the addition of oxygen takes place, then it is known as oxidation. So we can say it is a simple redox reaction because reduction plus oxidation, both process takes place simultaneously in this reaction. In simple terms, when addition of oxygen takes place, then it is known as oxidation, or when addition of hydrogen or removal of oxygen takes place, then it is known as reduction. Let is a simple comparison between oxidation and reductions. How do we identify when oxidation occurs and when reduction takes place? All these type of questions are clear here. Oxygen, when addition of oxygen takes place, then it is known as oxidation, and when removal of oxygen takes place, that is reduction. Hydrogen, when hydrogen removed from a compound, then it is oxidation. When hydrogen adds, then it is reduction. Next is electrons. When electrons are lost, that is metals. All the metals easily lose their electron and get the positive charge, so they are oxidized. Next, gaining of electron. When an element gains electron and bears a negative charge, then it is reduction. All the non-metals, most of the non-metals get the electrons and become negatively charged, so they reduced. Oxidation state. If the oxidation state increase, +1, +2, +3, and so on, then it is oxidation. But when oxidation state decreases, then it is reduction. That is +3, +2, +1, 0, and then negative also. So it is reduction. Agents. Oxidation carried out by oxidizing agent, whereas reduction carried out by reducing agents. Example of oxidizing agents: KMnO4. Either it is acidified or alkaline. Next is potassium dichromate, K2Cr2O7. It is purple in color, dark purple, and it is orange. Next, reducing agents. Example of reducing agents: hydrogen, carbon monoxide, sulfur dioxide, oxalic acid, and so many. Is an example of oxidation reaction. Oxidation of glucose during respiration. As we know, we take glucose from our food, which is the simplest carbohydrate, and it reacts with oxygen, which we get during breathing, and it forms 6 molecules of carbon dioxide, 6 molecules of water, and releasing a lot of amount of energy in the form of ATP. ATP is the energy currency of our body, which we utilize to carry out our daily life activities. So here, hydrogen is present in glucose, but now hydrogen removed from glucose, and removal of hydrogen is considered as oxidation. So it is an oxidation. Respiration is an oxidation reaction. Next, reduction of carbon dioxide during photosynthesis. Opposite to this, if we take arrow in opposite direction, and in arrow we mention HNU. HNU means sunlight or chlorophyll, which is present in plants, green plants, chlorophyll. Then, and remove ATP from this. Then 6 molecules of carbon dioxide, 6 molecules of water react with each other in the presence of sunlight and chlorophyll, form glucose and oxygen molecule. Here, carbon dioxide has only oxygen, not hydrogen. But in product, hydrogen adds. So, addition of hydrogen is considered as reduction. Addition of hydrogen is considered as reduction. So, photosynthesis is a reduction process of carbon dioxide, whereas respiration is a oxidation process of glucose molecule. The last topic of this chapter is effect of oxidation reaction in our everyday life. How oxidation reaction affect our life. So there are mainly 2 processes in which our life is affected by oxidation. First, corrosion of metals. First is corrosion of metals, destruction of metals. Corrosion of metals, that is destruction of metals. Next is rancidity of food. Next is rancidity of food. Rancidity is the rancidity of food. Rancidity means विकृत गंधिता, means food get spoil, food का खराब हो जाना. Corrosion. First is, what is corrosion? It is the process in which metals are eaten up gradually by action of air, moisture or a chemical such as acid on their surface. So it is a process in which metal slowly eaten up by the action of air or moisture, both conditions must be present, or a chemical that is acid. So we can say that metal gradually decreases or convert into some other form which cannot be get back. So it is a corrosion. Example, common example of corrosion is rusting of iron, formation of rust. Here it is showing process of rusting, how rusting of iron takes place. As it is shown in iron nail, oxygen molecules and drops of water on rain. Then the iron nail get rusted. So here 4 Fe4 atoms react with 3 oxygen molecule and 2x molecule of water. 2x is considered because number of molecules in the surrounding cannot be counted. So it is taken as 2x. Next it forms Fe2O3 dot X H2O, and it is the formula of rust. Here 2 molecules of this is formed. So it is a reaction of rusting of iron plus oxygen plus water, then it forms Fe2O3 dot X H2O. Two major conditions which are required for the rusting of iron. Conditions required for rusting of iron. Iron rusting के लिए two major conditions must be presence of air or oxygen. Next condition is moisture, damp air, that is water. Or instead of this, a single chemical is sufficient, that is an acid. An acid which can easily eaten up the wool metal object. So condition for rusting of iron, two conditions: air must be present and moisture, that is amount of water vapor. And next is, instead of this, a single chemical, that is acid, is sufficient for the rusting of iron. How do we protect the iron from rusting? The first is coating the metal part with oil or grease. We have to prevent the contact of metal surface with the damp air, so we have to oil or grease the surface of metal, which are antioxidants which act as protective covering for the metal. Next is painting the surface of the metal part. We can also apply paint on the metal surface. Third is plating the surface with zinc, that is galvanizing. We can also apply coat of zinc on the iron object, which is known as galvanizing. Next is plating the surface with tin. We can also apply the coat of tin on the iron object to prevent it from the rusting. The next effect of oxidation in our daily life is rancidity. What is rancidity? How do we prevent the rancidity of food? All such type of questions we are discussing here. The condition produced by aerial oxidation. Aerial means atmosphere. Of fat or oils in the food marked by unpleasant smell and taste is called rancidity. The process in which food gets spoiled by the oxidation of the food with the atmospheric oxygen, and taste and smell of the food get unpleasant, which is unfit for eating. So it is known as rancid food, and the process is known as rancidity. It makes food unfit for eating. Rancidity is also called vikrit gandhita in Hindi. Hindi language में it is called as vikrit gandhita. Methods to prevent rancidity of food. How do we prevent the rancidity of food? Adding antioxidant. We can add some chemicals which prevent contact of oxygen with the food, which are known as antioxidant. Example of these antioxidants are BHA and BHT, where BHA is butylated hydroxyanizole and butylated hydroxytoluene. Second is storing food in airtight container. We can store food in airtight container to prevent contact of oxygen with the food. Next is refrigerating food. We can also store the food in refrigerator, means fridge, by lowering the temperature. Here, lowering temperature prevent the food from rancidity for some time. Next is replacing oxygen in containers with another gas. For example, in chips packet. In market, the chips packet which are packed with the nitrogen gas instead of oxygen gas. Chips packet contain nitrogen gas instead of oxygen gas. So we can use such gas which are unreactive or prevent the reaction of oxygen with the food.